This is the fourth lecture in the series on fiber optics from the FOA. This time, we're covering fiber optic cables. Cable is just one of the components of a fiber optic system, but it's the first to consider, as it must be chosen to fit the installation environment. First, we'll examine the differences in installation environments and how that affects the cables. Then we'll consider various cable types and their use in those environments. Outside plant installations are just what the name implies. They're outdoors. Cables may be direct buried in the ground, pulled in conduit, or run aerially on poles. This means the cables must withstand not only the installation stress, but also the stress caused by weather and other requirements like rodents chewing on cables underground. Outside plant installations require different cables, more hardware, and different tools and test equipment. Premises installations are easier on the cables. They don't have to withstand the weather outdoors. But there are often large numbers of cables going to various locations. They're placed in cable trays or pulled in conduit or placed in J-hooks up on walls, and they eventually connect into patch panels and to equipment. The installation requirements are quite different because not only must the cables carry the signals and withstand the installation, but they must also meet building codes. Because of the wide variety of conditions to which they are exposed, optical fibers have to be encased in several layers of protection. The first of these layers is the primary buffer coating, thin protective coating made of UV curable acrylate, a plastic, which is applied to the glass fiber as it is being manufactured. This thin coating provides moisture and mechanical protection. The next layer of protection is a buffer that is typically extruded over this coating of the fiber to further increase the strength of the single fibers. This buffer can either be a loose tube or a tight tube. The next layer is a strength member, usually an aramid fiber, that can be used for pulling the cable. Finally, the entire cable is covered by a jacket designed to withstand the environment into which the cable is going to be installed. Tight buffer cable, zip cord is shown, distribution and breakout cables are used indoors. Outdoors, loose tube cable is used to allow filling the cable with water-blocking materials to protect the fibers from moisture. Zip cord is just two simplex cables attached by a thin web for convenience, since connections require two fibers transmitting in opposite directions. Zip cord is primarily used for patch cords or short indoor runs. It consists of two 900 micron tight buffered fibers, color-coded, surrounded by aramid strength members, and covered by a PVC jacket rated for flammability. Zip cord can be used for patch cords on patch panels or connecting up equipment. It can be laid in cable trays or even pulled by the strength members into conduit. Distribution cable is the most popular backbone cable for premises applications, since it offers relatively high fiber density in a small cable that is easy to install. Distribution cable has many 900 micron tight buffered fibers in the center, color-coded so they can be identified, surrounded by aramid strength members, and covered by a PVC jacket rated for flammability. Each individual tight buffered fiber can be directly terminated, but the terminations are not as well protected like in simplex or zip cord, so it should be terminated inside a patch panel or a wall-mounted box. Breakout cable consists of bundles of simplex cables inside a flame retardant jacket for use indoors. It's a very rugged cable for harsh indoor environments, often preferred for industrial applications. But it is bulky and heavy compared to distribution cable. However, you may directly terminate each of the individual breakout cables for connections to equipment, since individual fibers are protected inside individual jackets, making it very convenient to use. Loose tube cable is used for most outdoor installations because it has higher tensile strength for pulling long distances or aerial installs and can be filled with gel or powder to provide protection from moisture or water. Loose tube cable contains one or more tubes which can contain up to 12 individual fibers. The fibers are only coated with a primary buffer coating of 250 microns diameter to keep the cable size small, but each are color-coded. Loose tube cable is usually spliced, and the splice is stored in splice closures, or the fibers are spliced to pigtails for termination. If directly terminated, the installer must use a breakout kit to terminate the fibers as they are too fragile to handle safely. Breakout kits use 1 mm tubing called furcation tubing to sleeve the fibers before termination. Armored cable adds metal or dielectric armor over the cable, typically to prevent rodent damage in outdoor direct burial installations. However, it can also be used in any application to prevent crushing, even indoors. For example, below raised floors in data centers, where there are many heavy cables already installed and the potential of crushing the fiber cable is high. Armor cable is more difficult to prepare for splicing or termination, but ripcords are included to allow slitting the armor for relatively easy removal. Ribbon cable allows the maximum number of fibers in the smallest cable. Ribbons have 12, 24, or 36 individual fibers, and these ribbons are stacked in loose tubes or slotted cores. Ribbon cables have been made with over 2,000 fibers. This type of cable offers the maximum density of fibers, but the cables can be hard to work with. They require special tools to separate and strip the fibers, and ribbon splicers that splice 12 fiber ribbons at once. OPGW stands for Optical Power Ground Wire. It is a cable used as the ground for high voltage transmission lines, made possible by fibers' immunity to electrical interference. The fibers are inside plastic loose tubes, which are then covered by welded hermetic metal tube, covered then again by electrical conductors that are also the strength members. Finally, it's all covered by a weather-resistant jacket. The fiber is suspended from the power line towers, then the cable ends are brought to the ground to be spliced. Splice closures are typically mounted on the power line towers. Air balloon fiber is an alternative to cable. Instead of installing cables with fibers, you install a cable of open tubes. After installation, you then blow special fiber into the tubes using high-pressure compressed gas. Blown fiber can be used with multi-mode or single-mode fiber, or a combination of the two. It requires special fibers designed to be installed this way. They are smaller and coated with a special plastic that creates less friction. Blown fiber offers easy upgrades. Blow out old fibers and blow in new ones. It allows easy installation of the cable and easy installation later of the fibers, but special equipment is required for the installation, limiting it to contractors who've made an investment into equipment and training. These two terms can often be confusing as people mix them up. Hybrid cable includes two fiber types, typically multi-mode and single-mode, and is common in premises backbones where it allows upgrades to higher bandwidth systems. A composite cable includes fiber and copper conductors, either for power or signal. All premises cable must carry identification and ratings per local building, fire, and electrical codes. Cables without marking should never be installed indoors as they will not pass inspection. Inspectors are generally not inspecting fiber for electrical safety unless the cable is conductive, but are inspecting for conformance with fire codes. While cost is always an issue, it's most important that the cable chosen is proper for the application, has enough fiber for redundancy and upgrades, meets environmental requirements, and has appropriate hardware available for the application in which it will be installed. Next lecture will be on termination and splicing. We're the FOA, the Fiber Optic Association, the Professional Society of Fiber Optics.